Hi, in this set of videos we're going to be looking at solving exponential equations. When we're solving exponential equations, there's really three potential types of situations we'll find ourselves in. The first is that we are able to get our equation into the form b to the x is equal to b to the y. That is that we're able to have the same base on each side raised to an exponent and nothing else in the equation. There's nothing added to each side and there's nothing multiplied on each side. If we're able to get our equation into this form, if our bases are the same, the exponents are the same. So this is a really nice way of solving. If our bases are the same, the exponents must be the same. The next type of equation that we can solve is if we are able to get a base raised to an exponent on one side is equal to a number on the other side. There's nothing being multiplied in front over here, and there's nothing else going on. We want to condense everything down to one exponential on the left and one non-exponential on the right. If we're able to do this, we can rewrite our exponential using the definition of logs, which will be x is equal to log base b of y. Another way of thinking about this is you could take the log base b of both sides and log base b of b to the x is equal to x, as we've seen before. Our third solving type is if we are able to get a to the x is equal to b to the y. That is, you have two different bases with exponents on either side. In this case, we must take a log or an ln of both sides. I personally like to take ln, but you'll take the ln of each side. The reason you'll do this is our properties of logs tell us that an exponent inside becomes a coefficient outside. So taking the log of both sides is going to allow us to get that exponent down. We can also use this method of solving solving exponential equations. In this case, if we want to, if we've got a base that's not something we're familiar with. In our next video, we'll look at some examples of how you'll apply these.